Alright, so here we are again, and I'm doing something different. I'm out of app mode, out of gaming mode, and I'm in 3D modeling mode. So this is kind of a thing I've been kicking around for a while, and I just wanted to kind of get it done. So here I am, and before I get started on the actual modeling, I thought I'd go through my process, because some people might find it interesting. So like many 3D modelers, I use reference imaging for a lot of my builds, and the first step of that is usually just going to Google or Bing or wherever and searching for the thing that I want to model. In this case, I did a search for sawhorses, although I'm kind of cheating here because I already have my source image finished, and I'm going to show you. This is actually like the perfect sawhorse. And one of my hobbies is woodworking, so I actually know what I'm talking about here. A lot of times people 3D model stuff and they don't really know what they're talking about because they don't have actual experience when they're with the props that they're building. So a lot of times you just get something a little more atypical. But the reason I'm showing you the perfect sawhorse and then the reference images is because I wanted to point something out here. This is an abomination right here. For some reason, this is one of the most common sawhorse plans you'll find on the internet, and it's actually a horrific abomination. That's a total piece of crap. Never build this sawhorse. There's so many things that are wrong with this. It's just kind of mind-boggling that anybody ever thought that this would be a good design. This is an example of someone who had no idea what would make a good sawhorse, and they kind of just threw this illustration together, which looks all flashy and fancy and professional, but they didn't have any real practical knowledge about it. So this is the kind of thing that's really important when you're doing research. And just to point out why this is so bad as a design. So that they tried to create this synthetic I-beam here out of 2x4s, which would make sense if there was some kind of like vertical or consistent load along the whole beam, which is the whole reason that I-beams are so effective from an engineering standpoint at supporting weight. However, you can see the attachment points here. The screws come in from the side here on this side support strut and go into the bottom part of the faux I-beam, and then this screw just goes into the middle portion of the beam. It's horrible. So like you're losing all of the structural integrity of the I-beam due to the attachment points. And then furthermore, like what's really bad here is the angle. There's no like if you could see this zoomed up from another angle, you'd notice that this corner is vertical, right? And so this is a vertical corner that's hitting an angled beam. So like the point of contact is just this tiny little line across here. And then and this one up here, it's also at an angle. The tiny little line of this edge is touching the top of this side support. So you're not taking advantage of the structural attributes of the boards or anything, and this is just ridiculous, is what it comes down to. So let's compare that to this sawhorse design, which while it's a little more complicated, just to go over like basics of engineering here, is that like top loads are exerting force on the structure and how the structure is composed. So you have to imagine a heavy weight on top of all of these surfaces pushing down constantly, and that weight is transferred down each of these beams into the consecutive beam until it reaches the ground. So anytime you have weight pushing down on another part of the structure, it's either going to be trying to push it to one side or the other, because that's how force works if it's not balanced correctly. So it's going to be pushing straight down and to both sides, trying to tip this over and collapse the whole structure. So when you have weight that is pushing down in such a way that the maximum amount of that weight is being distributed throughout the structure in a more or less equidistant, force sort of way, then you're going to create this most stable possible structure. The one thing that I don't like about this design, which actually is minor, however is still not ideal, is that this beam right here touches this strut right here, which isn't good in one sense because it creates stability for this strut so that it's not likely to skew up or down. However, if a heavy enough weight is placed on top of here and it's pushing down hard enough on this strut, it's also forcing, putting force against these joints right here where the cross strut is screwed to the side beams. But otherwise, if you just look at this, due to the angle that these boards are cut, the weight is going to be distributed very evenly all the way down to the ground. This cross brace is holding these two legs from being spread any farther apart. And then this center beam here is bracing the tops of these boards so that they're not either going outwards or inwards. And overall, it's a much stronger, far more superior design to this ridiculous contraption here. Although this does have side bracing, which this sawhorse does not have, which if you really wanted to go overboard and build your sawhorse like an absolute tank, you could add additional cross bracing. But anyway, I feel like I've talked this into the ground. So anyway, when I'm researching, like here's an actual, oh, this is a 3D model. Some poor sucker actually made a 3D model of this horrible sawhorse based on that illustration, which was probably in Popular Mechanics or Popular Science or something. You can see right here this big gap and how that tiny little force corner, like all the force is reduced to the surface area of that edge is pushing into that piece of wood. You never want to see this kind of thing in any kind of structural engineering. It's really bad. You always want faces to be flush and touching like this, so there's no chance of the pressure exploding out of there. But anyway, like I was saying, when you are going to do a 3D model and you're looking at your source images, you want to get a diverse range. For this particular project, something as quintessential as a sawhorse, it's something that you're going to want to be creating both as a generic object that is instantly recognizable, but also that incorporates as many advantageous features as possible, so that you're creating a model that's actually worthwhile and not just a piece of crap that should never exist in the first place, or not even in a virtual world. You can see how popular this design is. It's such a waste. That lower beam is just like, I mean, it's intuitive because people think of I-beams as being strong, and it is a strong structure in and of itself, but the support of that structure is what's really important, because it's something that is off the ground. It's not like you're building a skyscraper, you're building a sawhorse, which is why it doesn't make sense. It's really tragic. This is a very common design for high-end woodworking, but it has some flaws too, like the fact that this cutout here creates sort of a sharp angle here where there's a lot of stress, and so the board is quite thin here. There's other disadvantages to that design too, but another nix on that particular design. So yeah, anyway, I'm just looking through all these sawhorse designs, getting an idea of kind of what I want to build. Here's another, this is a really nice sawhorse design. It's pretty common too. And then of course there's these like ultra cheapo ones that use metal brackets for reinforcing the joints. These are totally fine in real life. They're actually quite strong, although they tend to fold up unexpectedly on you when you're working with them. Yeah, so there's so many grades of sawhorse that you can go through. Some are really high quality, some are really low quality, some are designed to fold up. Yeah, I spend, like a few minutes looking at source images. I think it's a critical step, and one of the steps that you should put a lot of time into, because the more you see and the more you learn, the better you'll understand like what makes a good sawhorse and why should you 3D model one version versus another. Another thing I like to do is often I will incorporate the features from multiple different real versions into a single version, although in this case I'm just going to straight up build this version of the sawhorse. In fact, now that I saw the version I was looking at in here, maybe there's a good plan for that. Here we go. Oh, it's just on Pinterest. Might be able to actually get a blueprint of this particular sawhorse. God, he actually copyrighted it? Really? Tumblr, huh? Just like going all over the internet trying to track down this one design. And like, it's not even loading. So anyway, wasted enough time on this. I got my source image. I got my plan. One more thing that I am going to look up here. More references. I like to build everything I build to scale, so I looked up the nominal dimensions in millimeters of 2x4s. So I want to make an actual to scale version. Alright, so I'm in SketchUp here. And the first thing I'm going to do is model a 2x4. So that's 38 by 89 millimeters. And then the length is kind of arbitrary. If I had plans for this, I would know, but I can guess. This is probably 3 to 4 feet. So I'm just going to do 4 feet. That's 48 inches. Let's see what that is in millimeters. So I'm just gonna round it off because I don't really like working in imperial if I can get away with it. So like 1200 millimeters, like 1.2 meters. That looks really long. Now I can flip this in various ways and change the orientation right away to mimic like real life and real gravity, but it's just as easy for me to build at this orientation, so that's what I'm going to do. I'm going to lay down some grid lines. So what I'm building here is the top two boards, and then I'm going to create these vertical struts. But first I'm going to just align these together, and then I've already forgotten the measurements, so it's 38 millimeters. Okay. And most of the time I'm just going to copy and paste and then rotate and so forth. This is all pretty standard for 3D modeling. One thing that I might introduce into this session is the use of components. However, this model is so simple, probably not gonna get that far. So this looks like it's about probably not even 2 feet, but it could be 2 feet. So I'm just gonna 24 inches. Well, so I'm just gonna run that down. So 600 millimeters. So I made these objects so that I wouldn't have to worry about them sticking together, so that I could rebuild the model any way that I felt like rebuilding. Okay, so the nice thing about a sawhorse, for example, is how it's more or less a symmetrical design. Now, if I was doing components, I could just cut these in half and copy one side over, and then make my work take half the time because I only need to build one side. And I may actually do that. In fact, I think I'm going to. This is just a little like time-saving technique, but it also helps in other ways, which I may explain at some point. So 600. There's the halfway point. And now here's one technique I use in SketchUp for slicing. There's probably much easier ways to do this, but I find this is pretty efficient. So I just create like a box that's offset from the center point, and then I create a square. And so right now it's not going through any of these objects. I have to explode these two. And then I just select everything and go intersect faces with model, and that actually slices right at that point through all the objects. Kind of hard to describe exactly what's going on, but you probably get the idea if you see it a few times. So I'm cutting these open here on the ends because they're actually going to be joined together. Yeah, so here I have a little bit of a problem. If I explode this right now, it's going to join with these two objects, and then I'm not going to be able to move it. However, I already know that this is basically how it's going to be positioned, so I can get away with that for now. So I'm going to select everything and make a component, and then I'm going to copy that component and flip it along blue and then attach it here. So now I've got exactly what I had before. The only difference is when I make a change down here to this side, it's going to affect the the other side. So in other words, I only have to model half of this to complete the whole model. Although honestly, it's not a very sophisticated model, so normally I wouldn't do this for such a simple model, but I thought it would be cool just to demonstrate how powerful that technique is. So I think I've got my 2x4 template here. What I'm going to do is just copy the end of the board and extrude that to 600. So I've just created a duplicate of this using a slightly different technique. But this is where things get a little tricky because this isn't one of the angled pieces, and there's no way to know exactly what this angle is without a blueprint. However, I can kind of guess. It looks like it's about 15 degrees, and it can be verified visually. So yeah, 15, that looks about right. So you'll notice in the reference the top is cut at an angle, which is probably 15 degrees. So since I just rotated it 15, all I have to do is use my protractor to get that angle. But let me check and see what's going on here. This one goes at the bottom. It also looks like, I can't tell from the resolution, but it looks like there's a little shave off there too to create like a flat face on that edge as well. I'm not gonna go that far because that would just be overkill for a 3D model, but in real life it seems like that might actually be a good idea because it would reduce those corner stresses a little bit. Okay, and the bottom is also at a 15 degrees, it looks like. So my only reluctance right here with this particular cut is that I'm gonna have to extrude this probably to create the right length. Now let me explain what I'm talking about. So this is a 2-foot section, but this is obviously longer. It's probably like 3 feet, I would imagine, at least. So in order to get that the right length, I have to extrude this farther. However, since it's at an angle, I have to actually use a guide to extrude, otherwise it will go awry. So let's see what 3 feet is in millimeters. So is that 36? So 900. I think I'm just gonna go a meter. Well, no, I'm gonna round it down to 900 actually. That makes a lot more sense to me. Oops. Yeah, because a meter would be too long for sure. So now what I'm doing is sort of an atypical extrusion, which is taking a face and moving it instead of just extruding it along a line. Although I do have a grid line there that, or a guideline that's helping me with that, keep that extrusion on track. So now all I have to do is slap this into position here. Yeah, and now here's what you couldn't view on the. This is really illuminating here. So you see how there's like this little overhang there, and of course that's because it's an angled cut, so the surface area is increased. But if you noticed on the the physical version here, you can almost see a little cut there, and that was clearly to compensate for that little overhang. So I'm actually gonna have to do something similar, and it's 1.3 millimeters. So let's see, what's a good way to do this? There's many ways to sort of cheat in SketchUp, and this is one of them right here. So I'm actually making a rectangle, and then what I'm going to do is hide the rest of the object. Okay, that's unusual. For some reason this disappeared when I okay, it's connected. Alright. Well, sometimes you cheat and you get away with things, sometimes you cheat and you don't. So I'm just going to cut that, then I'm going to hide, and then I'm going to paste it over here. So now I have the exact cutoff that I need for that. Hopefully you understand how and why that worked. That was a little convoluted. And then I'm going to just use my protractor to get a vertical angle on that so that I can make my vertical line on the actual part. And now I'm really glad I did that symmetry from earlier with the components, because it's going to save me a lot of time in the long term. You'll see why in a minute. I mean, obviously, every little detail that I change on these objects is going to have to be duplicated depending on how much of the object needs to be changed. But thanks to the componentization, that change that I made has already happened in all the parts. Okay, so now all I need to do is slide this over, and it should align properly. I made a little bit of a mess with the topology. This is just leftovers from the part that I made to measure that out quickly. So yeah, now we've got basically a duplicate of the physical version. Looks like I lost a face there when I was screwing around with the editing. Not a problem, but I'm gonna have to clean that up later. So yeah, that actually works. Structurally, that works to our advantage for an actual sawhorse. And now I can just copy and paste this, flip along red. Okay, that didn't work, even though it should have. Flip along green. That didn't work either. Alright. Flipping isn't working because it's part of a component, so I'm just going to have to rotate it the old-fashioned way. Kind of annoying, but you gotta make certain compromises when you take shortcuts. Yeah, so there we go. We have the foundational structure. Now all I need is the cross brace, and it's basically a done deal. And for this part, I don't have to really, even though I have source, I don't really have to do any measurements exactly, because I can just use what's already been generated in terms of the structure of the model to create the next piece. So just got to make sure that I'm in component mode, so that my work is being duplicated, because I don't like to waste effort. If you're not in that component, then you're just going to have to model it again or copy and paste it, which is really tedious in component modes. So I just need to make sure I get my 2x4 measurement 38 millimeters. And this will automatically generate these angles for me. So, I mean, you can see how extensively I use guides. Like, I rely on them pretty heavily. But I also rely on what I think of as physical guides, which is like what you saw earlier, where I took that, that's curious. It's a flipped face. Where I actually made an object, a two-dimensional object, on one of the 3D objects to get a length. So yeah, so this model is essentially finished, and now it's just a matter of cleaning up the mess I made. Before I do any of that, I'm gonna group the whole thing, and then I'm going to change the orientation so that it's actually like a real world object. That's curious. That's like floating off the ground for some reason. Not sure I understand that exactly. We'll get to the bottom of that in a minute. Okay, so I like to put my objects right on the corner of the axis so that there aren't any surprises when I import it into other programs. And now I'm just going to explode everything here, which means a lot of selecting and exploding until the whole thing looks like this with the little dot pattern. And I can double verify that by triple clicking. And then I'm going to make it a group again and explode it again. And what that does is it joins a lot of these faces together that otherwise wouldn't be. So in the past I've used a lot of plugins to do my cleanup, but in this case I don't really have any of those plugins installed right now because I just upgraded my system. So I'm going to be doing kind of a manual repair, which is kind of nice sometimes. So I'm hiding all these outside faces so I can see what's going on inside the model, and this is the thing that I wanted to start with right here, is getting rid of these internal faces that are basically unnecessary for a complete model that's non-manifold like I'm trying to generate. What I will be leaving is the all these outer lines, which, like this line right here, like that's not necessarily the line you would want on a 3D model. You might just delete that and then use a texture to put that in. But I like to leave as many of those lines as possible so that, and this is just kind of a weird idiosyncratic thing that I have with 3D modeling. I like to pretend that the 3D model is somewhat real. So like I like it when the geometry of the 3D model can match what would be the real geometry of the object if it was not a 3D model, which is kind of weird and confusing, but whatever. So this is about right. This particular face right here is not really going to exist on the inside. I mean, it would in real life, but the internal faces, it's okay to get rid of those because those are invisible. It's only the external ones that are really important. So that is it for cleanup, I think. Pretty sure that's all of the potentially infringing internal faces. Yeah, I don't see any more. So then just unhide everything. And I'm going to do this triple click group ungroup again. So presumably everything's good on the inside of the model. Now all I have to do is triangulate faces, but I'm gonna save this first. Like if this was a more complicated model, I would have saved many versions, but I was pretty confident that I wasn't gonna have any real trouble modeling this and that the program wasn't gonna crash because it was a very simple model. There are fine details in this that I'm gonna add when I texture it. However, sometimes depending on the complexity of the details, what I'm talking about are these screw points. Alright, I'm going mute for a minute. I got some visitors, so I'm just gonna be silent mode for a bit. Alright, I'm back. Sorry about that. What I was doing was manually triangulating the faces. This is not something I would normally ever do. However, I thought since it was such a simple model, I might uh, derive some benefit from just playing around a bit with the triangulation possibilities. Because normally I use an automated function. However, I always do some manual adjustments like this, for example. I added this line so I wouldn't have an incredibly long and narrow polygon. And this is, once again, this is not like any sort of science or rational based behavior. It's just, to me, it's about the aesthetics of the substructure, like even below the geometry or meta geometry or whatever you want to call it. Like, I don't like it when models have really sloppy topology, and I will add a few polygons occasionally to sort of get around that problem. Because, I mean, let's face it, even in a really complicated model, in 3D modeling nowadays, like, the polygons counts in the millions, tens of millions sometimes for an object. This is like low poly, no matter how you look at it. So if I double the polygons in a couple parts of this model, it's no big deal. It doesn't add a meaningful data overhead in any way, and all it does is make the model cleaner, because if I didn't have this line right here, this point right here would be attached to this point. I'll show you what that looks like. And then you just have this super narrow polygon, which you can see here is just like hair thin. And I just don't like that. It bothers me from an aesthetic standpoint, so especially when I'm texturing, and it can cause trouble with like Blender, especially when I'm converting the model over. However, this just is not practical for even a small model like this. Manually triangulating is just a real pain in the butt. So I have a plugin that I'm going to use to triangulate the faces manually. The only problem is I don't have that installed right now. The little pro tip that I wanted to point out here is, before I started adding all these manual triangulation elements, I made the model into a group so that I wouldn't have to worry about creating polygons on top of polygons, although that actually happened up here. But what that does is, when you make this into a group and you start adding lines, they're where they should be, but they don't actually attach to the model. So for example, I can just select them all and delete them, or I can select them all and copy and paste them and then put them on the other side of the model and have a perfect mirror image of my manual, topology edits. Okay, I need to figure out how to install this plugin, and I don't know how to do that on this new version of SketchUp that I installed. And I don't have those plugins locally either. They're on my server. So I'm really up a creek here. Well, it's about 3 o'clock, so I think I'm just going to end the live stream here. I've probably already been obnoxious enough for one afternoon. I'm going to get those plugins installed, and then I'll come back to this model later on, maybe tomorrow or even later in the day, and finish clean up and importing into Blender, and then I'll work on the texturing and stuff like that. So you get to see the whole process. anyhow, thanks for watching. I hope you learned some stuff from this and it wasn't a complete waste of your time. I've recognized by now that I suck at live streaming, but I'm gonna keep doing it anyway just for kicks because it's kind of a fun way to pass the time while you're working. So yeah, thanks for watching and have a good one.